Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this ContainerJournal.com program, brought to you by TechStrong and Fairwinds. My name is Cody J. Brown. I'm the host of TechStrong Learning, and we have an exciting program ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. You should be receiving it by email. If you have any questions for our speakers, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. You'll also find over on the right side of your screen the chat tab, and we'd like to reserve that for more general comments, discussion, or if you'd just like to let us know from where you're joining us. We do have a couple of polls we'll be launching throughout today's program, so we do really want your participation there. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around. So our friends at Fairwinds today are looking into their crystal balls, and we're going to be looking at Kubernetes security strategies for 2023. I'm joined by Kendall Miller, technology evangelist at Fairwinds, Robert Brennan, vice president of product development at Fairwinds, and Ivan Fetch, developer at Fairwinds. So Kendall, Ivan, Robert, thank you all so much for joining me. Kendall, do you want to get this conversation kicked off?
I will take it from here, Cody. Thank you. Welcome, folks, to Kubernetes Security Strategies for 2023. If you came for interpretive dance, that won't happen until the end of the presentation. But hopefully first we will get through a whole bunch of Kubernetes security strategies and then move on to the fun stuff. So let's dive in real quick. Let's start with introductions. Robert, you want to go first?
Yeah, hey folks, my name is Robert Brennan. I'm VP of Product Development here at Fairwinds. I lead up all the development efforts on our commercial software. I've been working with Kubernetes for about 4 years in depth now, and in open source in general for maybe 6 or 7.
And Ivan?
Hi, my name is Ivan Fetch. I'm a software developer at Fairwinds, also working on part of the Insights team. I've been working with Kubernetes since about 2018.
Okay, and I'm Kendall Miller, technology evangelist at Fairwinds. I've been involved with Fairwinds for 7.5 years and doing Kubernetes or working with Kubernetes or talking to people who work with Kubernetes, depending on how you want to sort me, since about 2015. So excited to be here. Excited to be talking about this, and we're going to go ahead and dive in today. First, a little bit about Fairwinds. And I'm very distracted by the picture of me on the previous slide because I have a big beard and I recently cut my beard and I may or may not be insecure about it. But anyways, let's dive in. So Fairwinds. Fairwinds is a Kubernetes company. We have been doing Kubernetes for a very long time. As I mentioned, about the 7.5 years that I've been here has almost entirely been Kubernetes focused. It is our goal to help customers ship cloud native applications faster, with more cost efficiency and with less risk. The whole world's trying to move to Kubernetes. Everybody's afraid they're going to do it wrong. They're going to ship things that are inappropriately configured or wildly over-provisioned or wildly over-permissioned. And Fairwinds builds software that gives people confidence they can use Kubernetes correctly. So whether you're migrating to Kubernetes, you've been using it forever, or you have hundreds of clusters across your entire organization and you just need to bring some sanity to it, that's where Fairwinds plays. And we'll show you a little bit of our software towards the end of this. We'll have time for a brief demo for what we build. But the reason we're here talking about this today is we live in a world where security strategies in Kubernetes is an important topic. And as the world moves to Kubernetes and it becomes more and more the default decision, Fairwinds is around to help you with that. And also, it's just a world we live in. And so we're happy to talk about Kubernetes. So before we get much deeper, let's start with a polling question. Where are you in your Kubernetes journey? Are you just learning about containers in Kubernetes? Are you planning to use it in the next 6 to 12 months? Are you using it only in testing and development? Or are you using it in production? And we will hang out a little bit while everybody fills out their answer on their screen. You can click a button, hit submit, and let's see if I can cue the Jeopardy music from Cody. So See, right there, I went off script a little bit, kind of threw in my own little thing. Not sure that works for everybody, but I feel good about it. Okay, here we go. We're just. I got to fill the space with something. I'm learning about containers in Kubernetes, 36% of you. I'm using it in production, 43% of you. And this tends to be kind of the split we see. It's a lot of people who are just getting started or a lot of people who are already full-fledged using it in production and just a few that are in the process of implementing it. So glad to have you here, whether you're panicking about getting security right once you do make the move or you're already deep in the process. We're going to have things that are relevant to you today as we dive in. So we can wrap that up. I think I hit that button. There we go. Okay. Why do you need security strategies? And I think we're going to start with that. And I'm going to start with a quote that I like a lot here from Mike Tyson. Everybody has a plan until they get punched in the mouth. So it's kind of the same thing with security. Everybody has a security plan. Well, we're going to do X, Y, or Z until something horrible happens security related. And then you realize your plan was horribly, horribly wrong. That doesn't mean don't have a plan. Mike Tyson's not saying don't have a plan. And I'm not sure we should be taking life advice from Mike Tyson, even though the quote is, I think, still relevant. But let's start there real quick. Ivan, why should we have a plan in the first place?
Well, I think to avoid the second part of the quote, the equivalent to getting punched in the mouth in the security world is unexpected impact to your applications, your data, your interaction with customers, your reputation, and whether that's a breach, whether that's applications being able to crosstalk to each other in a way that you didn't expect, or whether it's an expanded attack vector from somebody because once they've breached some kind of perimeter, there's all sorts of access. Once you're past the initial walls of the castle.
Yeah. Robert, anything to add to that?
Yeah, I would just add, having that plan set up early on, as soon as possible is super important because security is very hard to do retroactively. If suddenly, you're 5 years into your company, you've built your whole application, you have a complicated stack, suddenly you realize we haven't done anything security-wise, you're going to have a lot of debt built up. So making sure you have that plan from day one is super important.
So understanding what does security look like in the world of Kubernetes is essential right from the beginning. If you're already running it in production, you don't have a clue. Well, it's a good thing you're here today. We'll give you some ideas on where to get started. But even if you're just getting started, it's a good idea to understand some of the paradigms as they relate to Kubernetes, some of the things that are different about the world of Kubernetes, because it is a completely different paradigm. Everything about cloud computing in the world of Kubernetes is done differently than when you had a server in your own server closet, or even when you had a baby server running in a cloud somewhere. And so it's good to have a plan. I will add one more reason that you need a plan. If you're at all in compliance world, like even SOC 2 compliance is a lot about just, you have to have a plan. You have to have a strategy. So we're going to be talking about that today. Also, the picture I like to think of is you're trying to avoid this. You build a security strategy because someday you're driving a car down a very windy road and you hit a guardrail, and the guardrail you hope to never, ever have to use. But it's there because you want a strategy for when things go awry. And not all guardrails and security plans have to be this devastating, keep the entire world from caving in. There is that's a nice thing to have. Please don't deploy a known CVE that people are exploiting by just randomly searching IP addresses and then mining all the Bitcoin on your servers, right? That's a super obvious, this kind of guardrail that's exploded in this particular picture. But there's also the guardrails that just say, we're going to help you not mess things up. So this is a picture of a bowling alley with some bumpers along the side. And, it's not the catastrophic effects. If you're bowling and a bowling ball goes in a gutter, you're going to be just fine. But you still want to avoid it. And you're going to have more fun if you do things the right way. and it's going to help those around you, especially when you're just getting started and just learning. So the guardrails, the strategies of security can be both life-saving, disaster avoiding, as well as just comfortable guardrails to help you get familiar until you're comfortable with how everything works. So we talked about why care, why have a security strategy. What are some Kubernetes security strategies? Talk for a second, Robert. I mean, I just mentioned it's a different paradigm than when you have servers in your back room versus in a cloud. Just talk a little bit about what makes Kubernetes so different that the paradigms change.
I think the big thing is that you with Kubernetes, if you're kind of following that DevOps model, you're giving a lot of control over to individual development teams to basically provision infrastructure for themselves within Kubernetes. And with that extra power comes a lot of responsibility, right? Those devs can do all sorts of things that maybe they wouldn't have been able to do in the old world, where they needed to go through a DevOps engineer who was going to spin up an EC2 instance for them. In the new Kubernetes world, they can just run a command. Suddenly they have an application running inside the cluster. They can run that application as root. They can access files on the host node potentially. They can run vulnerable containers. They can do all sorts of things that you might want to prevent them from doing, or set up guardrails to prevent them from doing. So I think it's that extra power that individual development teams have that makes Kubernetes a very different security profile than kind of more traditional infrastructure platforms.
Yeah, I would add the ephemeral nature of everything. When you're building servers to run forever and ever and ever, and you're bragging to your friends about your 27-year uptime. Not that I have a box that's been running for 27 years or anything that I'm actually specifically referencing in this, but that's different than when you're talking about containers and what does it look like in a container world to be secure. And it may sound like you would care less about security in container world because they're just going to be around for a little bit, so it'll probably be fine, but that's not the case. Anything I'm missing there, Ivan, before we move on?
No, nothing anybody missed, but to expand just a little bit on some of those points, I think the other piece that can be unexpected around Robert's point about developers can potentially do a lot is that not only are those vulnerability potentials a thing in the cluster, but also exposing new services that someone might spin up to the world, which, depending on the quality of that service and its security and its fitness, could also connect to other services, lead to data exposure or something leaking or being accessible in the world that you might not intend to be accessible. So if you are creating an ingress or a load balancer service and you don't have some good guardrails around that, it's possible for someone to expose something to the internet relatively easily or even accidentally.
Sure. Exposing something to the world. So it's different than when we were having LAN parties and playing StarCraft in our youths. Okay, so let's talk about a couple of different things that security strategies should cover. And we're going to spend a little while on this slide because it's got a bunch of depth. So I'll leave this up for a second, and then I'm actually going to turn off my screen share so you can see our beautiful faces for a few minutes while we discuss. And then we'll come back to slides as we go. But let's start with not allowing people to do more than they should. This is just starting with least privilege idea, right? You don't want to give people any more privilege than you should have to out the gate. And let's dive in with some of those things. You need a security strategy. And here's 3 ideas for big picture things to put the big buckets to consider in Kubernetes world, right? Let's start with this first bucket. Don't allow people to do more than they should. Robert, talk about insecure capabilities.
Yeah. So basically, when you're running a Docker container, you can pass around some configuration to it that says, kind of what permissions it has relative to the machine that it's running on. And so one of these things is you can add capabilities to a container, which kind of give it a little bit more access to the host machine. Typically, most applications don't need to do anything other than run their little Node.js script or whatever it is. Sometimes you have an application that's doing like networking type stuff, or some very baseline basically utilities that might be running as part of your infrastructure. Those might need those insecure capabilities, but your average application that you're serving an API from, or a web UI, doesn't need any special permissions or capabilities. And Kubernetes will give you the option to add those capabilities in the off chance that you need them. So it's important to make sure that most teams under most circumstances are not adding those capabilities, and even better, dropping the ones that are by default enabled.
Okay. And Ivan, talk about privilege escalation being allowed and how that's different from insecure capabilities. But wait, actually, before you do that, I said for this bucket, don't allow people to do more than they should. And that's true for people, but this is also, we're talking about workloads here and the kinds of settings we're putting around workloads, not just people having access. So then we'll come back to people having access. But yeah. Ivan, talk about privilege escalation.
Yeah, so privilege escalation allows the container to escalate to having more privileges. It's similar to a set UID binary that folks might be familiar with just on traditional Linux systems. So you essentially want to set in your security context of your container, allow privilege escalation false. And what that helps you do is if it helps you avoid if someone were to escape a container via some sort of exploit, it helps you to minimize not being able to escalate to having root or administrative access on the host where your container runs, which is a Kubernetes node where lots of containers and presumably different applications with maybe different types of data and so on are running. So you want to disable the ability to run as a root user so that a potential container escape has less possible permissions. So it's very, very similar, very related, integral to the previous topic that Robert just talked about.
Well, what's interesting about that is back to my point about insecure capabilities on the workload versus the people. I mean, it's a similar, in this situation, both of them. You don't want insecure capabilities and you don't want the workload to have privilege escalation allowed so that people can't do so. I mean, I guess it's people and or workloads, infected things, whether a person's putting it there or a person's actively doing it, whatever is going to bad happen from a person or from a computer. Wow, I'm really disappointed that I'm giving a talk where I'm like, it doesn't matter if it's a person or a computer that's doing the thing, because this is the blurring of our future inevitable merging of computer, man and machine, and we're all going to... Anyways, that's a topic.
I get it. You're trying to be nice to the robots just in case.
I don't want there to be recordings of me bad-mouthing the robots like 15 years before they take power, Ivan. Gosh. Okay. And then the next one is running as root being allowed. That's a thing that we want to avoid.
Yeah.
How's that different? I mean, it's the same idea. That's a privilege escalation and insecure capabilities, right? Is there anything that's different about that?
Yeah, same basic idea. You're giving that container some extra permission to kind of affect the host node and potentially other containers on that node. It's a good idea. It adds an extra layer of protection to prevent containers from running as root. There might be a little bit of re-architecting you need to do within your application to make that happen. Sometimes it just works out of the box, but it's definitely a best practice.
Yep, definitely a best practice. Okay, so I should pause and say, hey, folks, there is a Q&A tab. So if you have questions as we go, I do try to watch the Q&A tab as we go. Some webinars, people ask a billion questions. A lot of webinars, people don't say anything. But we will stop and address your questions. So if you have questions as we go about security strategies in Kubernetes, or even if you just want to ask Robert where he bought his sweatshirt, you're welcome to put that in the Q&A. I will probably more likely address the more relevant ones, but we'll see. Okay, for security strategies, another big umbrella category: don't allow avoidable known errors. So there's a couple things in this category, and I want to go first with just like there's some obvious best practices, and in the bucket of avoidable known errors is like everything that a experienced Kubernetes engineer would tell you not to do. And there's a whole bunch there that is hard for you to know unless you have an experienced Kubernetes engineer around, right? So you have two choices. You can go hire a very experienced Kubernetes engineer to help you avoid all of the known errors or the bad mistakes you're going to make or whatever, or you can implement software. And we're going to get into this a little bit later, both our paid software, but we have open source we can point you to, and there's lots of third-party tools out there where some smart engineer sat down and said, everybody messes these 10 things up. I'm going to write a software piece of software that keeps people from messing those things up. So there's different ways to go about that, and I would encourage you to take a look at the software that's available out there, and or consider hiring the smart people, because expertise is worth paying for. It saves you a lot of pain in the long run. But next topic on that, image vulnerability. So talk about image vulnerability. I don't know which of you wants to talk about image vulnerability. Known city things that are problems out there. Go for it.
Yeah. So every container that you're going to run in your Kubernetes cluster starts with a base image. That base image could be a base for Python or for Node.js, or maybe even more full OS, almost, if you will, like an Ubuntu image. And then you install things on top of that. And you want to make sure that that software that is your base, as well as the things you're installing on top of it, are up to date and doesn't have vulnerabilities. And vulnerabilities can happen at the time you deploy an app, but they can also be realized later. And so it's a constant check and assessment in your cluster for, do I have images that have vulnerabilities, so that I can make sure and address those and essentially rebuild and redeploy my app so that the container image that it lives inside of doesn't have those vulnerabilities. There's new vulnerabilities every day, and sometimes they're realized and they've been running in environments for a really long time. So one good way to help mitigate this is to minimize the unnecessary things you install in your container images. So it's tempting to put tools or things that help you debug inside your container images, because you might need those someday, or they might be useful in a non-production environment. And then you promote that same image into production, and so it has unnecessary stuff for your app to run that you might wish you had 1% of the time for troubleshooting. But you can leave a lot of those things out of your image, and you can use commands like kubectl or kubectl, or however you prefer to say it, kubectl debug, to start a temporary ephemeral container alongside your workload, and add an additional debug container for those debugging purposes. So that means you don't have to include that stuff in your image just for the 1% or 10% chance that you want to use it. So that's one example of how you can help streamline your container images so that there's less things that stand a chance of being found vulnerable.
Okay, yeah, there's appreciate that, Ivan. There was a relevant question that came through that we're gonna read here, and it is not surprisingly about Robert Sweatshirt, but it says, "What are your thoughts around Red Hat OpenShift Advanced Cluster Security for Kubernetes?" Well, I have some thoughts about this, but I first want to say, any piece of software like this, whether it's Fairwinds software or open source or third party or Red Hat's software, this is one of those things that I mentioned where you're taking smart people who have gone before you and come up with defaults and put them in place. Now, you may hate their defaults or wildly disagree with them, but it's a place to start that's better than what's out of the box. So, Robert, I think you've maybe been closest to OpenShift Advanced Cluster Security for Kubernetes. Correct me if I'm wrong about that, but why don't you start? Because I know enough about it to probably put my foot in my mouth, but I'd like to hear from you, who is probably actually knowledgeable.
Yeah, I guess what I would say is, in general with security, there tends to be a trade-off between security and usability, right? If you just want to get things working right away, no matter what, you can turn off all the security controls, and it'll be nice and easy that you can run everything as root and do all the bad things you're not supposed to do. If you turn on all the security controls, you might have to re-architect your application, change a whole bunch of things. I would say, from my experience with OpenShift, they push that dial extremely, extremely far towards the security angle and away from the usability angle, which if you're a paranoid organization, you're working in healthcare, you're working in finance, that might be the right call. But it has slowed me down in the past using OpenShift. The other thing that I'm not entirely sure on, but my impression is that OpenShift does not really provide a lot of easy ways to create kind of broad policies for exceptions. So they've turned on all the security controls. They're going to prevent you from running containers as root, for instance, prevent you from adding capabilities. When you do have an application that does need those things, it's not the easiest thing to provision additional access for yourself, or to create, kind of broad-based exceptions. You have to kind of, from what I remember, create individual exceptions for individual applications. So finding the right spot on that trade-off, I think, is important. I think OpenShift makes sense in certain scenarios. I think it doesn't make sense in other scenarios. And you might want to go with a policy system that's a little bit more flexible and user-friendly.
Yeah, thanks. Ivan, I don't know how much context you have around OpenShift products. Do you have anything you want to add to that or no?
No, I don't have anything really to add to that one.
Okay, yeah, I would just say there's very few people that I know that have used that particular product. All of them have said, how do I say this? One of the nice things about Kubernetes is whenever you run into a problem, there's someone out there who's run into the same problem because there's enough Kubernetes users. There's 1 billion people out there using Kubernetes. And that means there's a plugin for it. It's like WordPress. There's a plugin for it. There's a solved problem for it. There's an answer on Stack Exchange or Stack Overflow or whatever out there for whatever your problem is about Kubernetes. If and when you use OpenShift, you're now in a much smaller world, and you're going to be running into problems that very many fewer. Man, this is my native language. I think that's right. People have run into, and you're gonna have less of a fun time. And when you go to plug in one of those plugins, there's a good chance it won't work. And when you go to, so it's not necessarily a bad thing. That might be exactly why you're implementing it. But it is a complexity. So you
also might be tempted in such a scenario to turn off whole entire layers, if that's possible, of security things to get your one thing to work, which is, takes you
a whole other security strategy. That is a security strategy. Install the security software and turn everything off. So just to be clear, that is a strategy. Okay, we've got one more big umbrella to consider around security strategies that you should definitely be considering, and that is segmenting your people or teams by role. So Kubernetes has a concept of RBAC, role-based access control. Ivan, you want to start on RBAC?
Yeah, so you want to use RBAC. It's going to sound like I'm being snarky, but the core thing here that's the most important is use role-based access control to grant privileges to the people who will need to be interacting with Kubernetes. It can be very tempting to take that primary administrative user or role that comes with Kubernetes when you first set up a cluster and give it to people in your small company because it gets things moving. It's like Robert said earlier, where you can move faster by just doing all the things that you ultimately don't want to do in the end. And this is definitely one of those situations. So you want to use your own cluster roles to grant privileges using the minimum privilege model, that's common to security in general, right? Grant the least privileges necessary, which takes work. Like all of these things we're describing, running your application as root, like we've talked about a lot in the past, it can take effort. There are some container images that require to start up as root and then drop privileges, but that means that you have to run them as root for a little while. So you have to work around, not work around, that's probably not what I should say. You have to
work within the constraints.
Work within the constraints, but don't turn them off. So A few tips on RBAC. We have a very cool open source tool called RBAC Manager. It helps you simplify the amount of code that it takes for you to create a cluster role or a role and bind that new role to users or groups of users. So highly recommend checking that out. And then there's also audit logging, which is related to RBAC. As you're building your cluster and operationalizing your team around Kubernetes, have a line item to look into audit logging and how you can get at those logs and how to tune them for less noise so that you can find useful things in the signal that's left in your audit log. And one of the things that the audit log shows you is who's doing things, and it relates to RBAC. So it relates to user Ivan tried to delete this pod in the cluster. He was disallowed from doing that, or he was allowed by this particular RBAC construct. So
yeah, heck yeah, user Ivan. Stop trying to delete things in the cluster. So I'm going to go back to screen sharing here. Window, pick this one. Here we go. Okay, so for all three of these categories, we've mentioned a whole bunch here. I'm going to just talk real quick about some of the open source tooling that exists around this space. So RBAC, Ivan mentioned role-based access control, RBAC Manager, Fairwinds open source project. If you look up RBAC Manager, GitHub, you'll probably find our project. Don't allow avoidable known errors, image vulnerability. There's Trivy. There's what are the other things in this space, Robert? I've done some work to look into it, and I can't even remember what they are. There's a number of open source image vulnerability tools out there. Do you know what they are?
Trivy's the best one. I think it's the only one that has both an open scanner and an open database. I think it's the one that I think is the most popular within the Kubernetes ecosystem for sure.
Yeah. Okay. And then this top category of don't allow people to do more than they should. I mean, these are just common misconfigurations that we've seen people get wrong a lot. And we have an open source tool called Polaris, Fairwinds Polaris. You can look that up. That will check for many of these things. Does it check for all of these things, Robert? I think it does.
It does check for all these things and about 30 other things.
Yeah. So don't make the rookie mistakes. You can cover a lot of this by either hiring RBAC Man, the consultant, or putting in place some software. We collect a lot of statistics across lots of organizations about what things they're getting right, what things they're getting wrong, and we have seen across organizations that 54% of organizations are leaving over half their workloads open to privilege escalation and thus security holes. So that's significant. Almost half of organizations are leaving almost half of their workloads open to privilege escalation. That's a problem. So worth taking a look at what you've done in your own cluster. Where do we implement guardrails, these security strategies, and call them guardrails, call them security strategies as it's specific to your cluster? There's three different places you're going to want to put in place. CI/CD, like from the code repo to the CI process, at the time of admission, and also in runtime. Now, it may sound like time of admission is the same thing. If you're not living in Kubernetes world, there is the idea of admission is a little bit different from CI/CD. Most people are going to be admitting things into Kubernetes via CI/CD if you're putting that in place. However, there's a way to go around that and just try to push something straight into the cluster. And so Kubernetes can check at the time of actual admission into the cluster and keep people from even going around the CI checks, for example. But you also want to check things that are in runtime, because sometimes you deploy a container that looked safe on Friday, and by Monday we know that it's running a known vulnerability that was discovered over the weekend. Did I get that right, Robert? Anything I said completely wrong right there?
No, you nailed it.
Man, it feels good to nail it sometimes. Yes, feels real good. Okay, we talked a little bit about some of this. A few more open source projects, how to implement your strategy. We touched on Polaris, that checks for common misconfigurations that we've seen. Ivan, can you touch just briefly on Nova and Pluto?
Sure. So Nova is going to help you realize when there are updates that can be made for Helm charts that you've deployed in your cluster. So there's a lot of different Helm repositories out there that can supply you with Helm charts. And so Nova is a great tie-in for that. So it's going to give you alerts when those Helm charts have updates, that often those updates might exist because there's been some kind of a security vulnerability that's been addressed, let alone new features and all that. Pluto is a tool that's going to help you get advanced warning of Kubernetes APIs that are deprecated. So like with any piece of software, there's the instruction set that we talk to Kubernetes with. These are these YAML manifests, or they also get encapsulated in Helm charts or tools like Customize, et cetera, et cetera. And it's how you tell Kubernetes what you would like it to do on your behalf. Please deploy my application using this container image with these settings, don't run as root, and so on. And those instructions use a particular API or way of talking to the Kubernetes control plane to tell it what to do. And as Kubernetes gets updated with new features and things are realized that could be implemented somewhat differently and in an improved way, those Kubernetes APIs change and they become deprecated so that eventually the old methods can be removed and we can continue moving onwards, upwards, and forwards. So sometimes those deprecations and removals of APIs can be a surprise for customers. During cluster upgrades is the last time that you, the most inconvenient time that you want to realize an API that I'm using to deploy my app is literally no longer understood by my upgraded Kubernetes cluster. And I might be trying to deploy an application because it's an emergency for my business, and all of a sudden I realize I can't deploy that. So Pluto, this was a somewhat lengthy anecdote to be able to say that Pluto is going to help you to regularly check your resources in your cluster to make sure that you're not using APIs that are already deprecated and will potentially be removed in some future version of Kubernetes. We've had a lot of really great use of this tool internally and appreciation by our customers, and it's awesome that it's something that's open source, that everybody can avoid anecdotes like the one I just told and not find yourself in that situation.
Great. Robert, touch on OPA real briefly, and then we'll dive into insights. Please, if you have questions, we're going to have some time for Q&A here towards the end as well. So if you have more questions, feel free to keep them coming. But talk OPA, Robert.
Yeah, so Polaris is great because it comes with about 30 built-in checks, based on our understanding of best practices. Polaris does support custom policies as well. So you can write JSON schema that will run against any resource in your Kubernetes cluster. And essentially, allow you to create your own checks, say if you want to enforce a labeling scheme on all your workloads or something like that. So this concept of custom policies really comes into play when you get past the kind of broad best practices and are trying to put into place policies that are really specific to your organization. Maybe you only want to use Docker images that come from a set of registries that you own. Maybe you want to enforce a labeling scheme, anything like that. So like I said, Polaris can do some of that, but an even more powerful engine is called OPA. OPA is it gives you much more basically programmatic access, so you can do all sorts of things to check to make sure your workloads are conform to your own custom policies.
Yeah. Policy engine. And so then finally, in large multi-cluster environments, we create a software at Fairwinds called Fairwinds Insights that makes operationalizing all of these different security bits more doable. It's one thing to install open source projects on one cluster and keep them up to date. It's another thing to do it across tens of clusters or hundreds of clusters. So Kubernetes governance software from CI/CD through to production is Fairwinds Insights. Helps you with a lack of visibility into security and compliance risks, helps with cost optimization, helps with policy, guardrails, and security. And so I'm actually going to dive in and show that to you right now. There's a lot in Fairwinds Insights, and we're not going to get into all of it, but I'm going to give you a quick high-level overview. When you log into Fairwinds Insights, you're going to get an overview of your organization that looks something like this. So this is an organization with, I don't know how many clusters this is, 15 clusters. And you can see my favorite cluster is offline, which still makes me sad. But we give you an overall organizational health score. This organization is doing pretty good. It's got an A and health score across each individual cluster. And you can click into a cluster and it'll take you to a cluster overview page, which I have loaded in case it doesn't load fast, but look at that. So action items above the line are where new action items are introduced into the cluster, and below the lines is where we've knocked them out, so improved upon things. You can see the health score over here for the cluster and all these different things that we're checking. So this is over 2,000 different things in this particular cluster that we've checked for. And you can see we have 26 critical issues. So we do prioritize those issues to make sure you get to what really matters and you can go straight there and address it quickly. We track your health score over time as a demo cluster, so the health score isn't particularly interesting. We also have some cost logic here, so that you can see how the cluster is how much the cluster is costing you over time. Now, where is this all coming from? We are pulling together a bunch of open source projects, some of which we mentioned today. So Polaris, our tool for common Kubernetes misconfigurations, Nova and Pluto, deprecated APIs, and out-of-date Helm charts that Ivan mentioned. We also support Trivy, checking for container vulnerabilities, KubeBench, KubeHunter. We have support for OPA, so you can write custom policy. There's a whole bunch here that we operationalize across lots and lots of clusters. And that rolls all up into a big list of action items. Now, this is going to show you all the things that are going on in your clusters across the entire organization, or you can drill down into one cluster and take a look. You can sort by priority. So here you can see, we have critical issues, high issues. You don't have to be a super senior Kubernetes engineer to understand what these things are. You can click on one, it's going to pull out and say, here's the problem, here's how to go about fixing it. Shouldn't be allowed to run as root, right? This is one that we addressed today. Here's how to go about fixing run as root. Now, if you're like me and you see this big long list of 138 results, oh my gosh, that's a big long list of all the things I got to go fix. And across the organization, it's thousands of things. That's super overwhelming. And we don't want to be one more tool in your life that tells you you're not doing everything perfectly. And so Fairwinds Insights has shifted a lot of this left. So you can write policy in your organization and empower the engineers that are actually deploying these workloads into your Kubernetes clusters to do it in a way that makes sense. So here you can see an engineer pushing in a workload that has some issues with it. And in GitHub, where they already live, you see a whole bunch of action items here, as well as the severity of those action items. And we can block the deployment as a result of this. You can set a threshold and say, hey, anything that's critical or above should block a deployment. Everything else should alert the user, but not block it. You can choose whatever those thresholds are. And then an engineer can just click on this, go into Fairwinds Insights, see the full report, understand, like those action items where we show you how to fix things. You can go in and fix it, improve upon it over time. And we also have some cost bits. So this webinar is primarily about security, but sometimes you need to save some money in your Kubernetes cluster so you can afford the security tooling that you're putting in place. So let's say you're here because you really, really, really want security tooling in your Kubernetes clusters, but you're not sure your CFO is going to sign off on it. Using something like Fairwinds Insights, you're going to save money in the process because we do have cost metrics, cost visibility, so you can see where you're going to be able to cut out the fat. And this is what that looks like. So we break down across one organization. So this is one cluster, and this is the relative total cost of all these different workloads, the daily cost of the different workloads, and then down here I can filter by workloads with recommendations. So when we've said that you should set something to a different price. So what's unique about our software is a lot of times we're even going to tell you to spend more money because we think the quality of service that you've selected is going to require more resource requests and limits. But sometimes we're going to save you money. So here's an example where we have a Prometheus server running, and here's where our requests and limits are currently set. This is the request, this is the limit, but our recommendation is all the way down here because we can track that actual usage over time across memory and CPU and give you recommendations that are based on actual usage. So this is a great way to save your organization time and money, rather than your engineers going up and clicking that apple and saying about this Mac and then writing down how many gigs of memory and how fast the CPU is and just requesting that same thing because they don't know and it works on my machine, so I'll just duplicate my machine, right? That's how Ivan does it. So that's why I'm throw you under the bus here. And then I'm kidding. Finally, we recently shipped some new cost functionality where we actually break down across all of your clusters so you can see which of your clusters are costing you the most money, your average build cost, your total build cost, what your cost would be if you took our recommendations. You know, again, in this case, we're telling you to spend more money. So a lot of tools out there will only tell you how to cut, and we'll tell you how to save money. In a lot of different places, a lot of organizations, we save them a lot of money, even just in a proof of concept trial with the software. But sometimes we're going to tell you to spend more because you have chosen a quality of service that's going to cost you more money. And we're approaching the problem from configure things correctly, security, efficiency, et cetera. And so we will tell you to spend more money when that's really necessary. Now, there's a whole bunch more here. We check for vulnerabilities across the organization. We touched a little bit on that. You can scan repositories, whether they're in Insights at runtime or not. We have compliance dashboards. So if you're putting in place a security strategy for the purposes of compliance, I touched on that. SOC 2 is an example. You can have your reporting right in here, click a button, download all of that proof that you need to report for SOC 2. You can compare across clusters, you can write custom policy, and you can even create automation for, say, every time somebody pushes a service into this namespace, tag that team in Jira and create a ticket over here. There's a lot more in Fairwinds Insights than I'm able to show you today in a brief demo, but if you want to see more, reach out to us. We're happy to dig in deeper there. But let's spend a little bit of time on Q&A as soon as we're done with this polling question. What is the greatest opportunity to improve your Kubernetes environment? Do you want help getting help? Do you want help getting help? Do you need to get help with the basics? Do you need a general best practice assessment? Would you like to improve the security posture of your clusters? If you're here for this webinar, select that one or you're doing it wrong. Do you want to save money? Do you want to improve the reliability of apps running in Kubernetes? And I don't actually want to influence your answer here. So submit whatever you think is best, and we will collect that in our poll here. Open. Come on, people. I know you're there. You can click that button. There we go. Responses are coming in. Takes people a while to figure out where those radio buttons are. Okay, so right now we're seeing a pretty even split across saving money, getting help with the basics, and then improving the security posture of your clusters is growing in popularity, as it should. Okay, this is a security webinar. You can keep filling it out for a second, and I'll go on. Let's see. Yeah, here we go. So we'll have a link to this. We'll also send that out in an email, but there'll be a link in chat here. For a Kubernetes configuration benchmark report. We do also have, so this is benchmarks around security, cost optimization, and reliability. So if you're curious how well your organization stacks up against others, this is a benchmark report for that. We do have lots of white papers on our website. If you want to come look at security best practices, et cetera, we have those as well. And you can get a demo at that link there as well. So let me see if anybody has questions in the Q&A. Here's one question to get us started here. It says, what kind of security checks, I'm assuming it means like guardrails, controls, does Kubernetes have out of the box? So, Ivan, I install Kubernetes. It's ready to go. It's nice and secure, right? Is that true?
It's becoming more and more true every day. That's what I'm going to say.
So, am I starting? Is that like saying, football's
it's a nice way of giving credit to all the various Kubernetes developers and special interest groups and so on and so forth who have been continuing to work hard to make Kubernetes more and more secure by default, which it hasn't always been. So the other thing to say here is that there are less Kubernetes secure by default. There is less security by default than you might think. And this has been the juxtaposition between it working and it being secure, right? Everyone's security story is a little bit different. Everyone's needs are unique. And so in the earlier days, especially, Kubernetes was experiencing, I tried to deploy Kubernetes. I tried to deploy my app and run things in Kubernetes, and it's not working. What gives? And so security was relatively open for quite some time. So that's definitely improving, but it's why we have tools like we've been talking about, and recommendations like we've been walking through to help folks be more aware of the kinds of things that they can look into to help their stuff be more secure.
I feel like I feel like saying it's getting better and better is a little bit like saying tabletop football is the fastest growing sport in America. And that's because there was one person yesterday and there's two today and there's going to be four tomorrow. And so it's like doubling every day. But like when you start from nothing. So, I mean, how close to starting from nothing was Kubernetes, Ivan?
How close? I mean, it has been very, very open, right? It's been like I built a house and I hardly had any walls in the house, and I could definitely come and go as I pleased, and I could do lots of stuff inside the house. But it was also easy for other people to come and visit, potentially, depending on if I created some services that were more easily accessible from the internet, or if my Kubernetes nodes weren't as protected from internet access, depending on the network that they were on. And the defaults in Kubernetes have leaned heavily towards operational and less heavily towards that thing that we've talked about earlier in this webinar, which is like, I think we happen to be talking about OpenShift around, if you twist that security dial far, far to the right, also things aren't going to work as easily or as in a straightforward manner as you might wish they did. Because there's all these controls. So it's been pretty open, and there's been a lot of good focus in the Kubernetes security community on how to have a better mix of, well, let's not break everything by making it more secure, but let's try to do both. Let's have things be more secure out of the box, which includes more awareness, more documentation, turning on some features by default, also in a way that they kind of socialize themselves through feedback in log messages and documentation about, hey, this thing that you tried to do didn't work, and the message that you might have gotten from an admission controller that denied your request to deploy a resource in Kubernetes is hopefully telling you more about why that is. So we definitely saw that in our Insight software as an example, where you got to see those remediation recommendations along with, hey, your thing is insecure, or hey, your thing is not as efficient as it could be, and here's how you fix that.
Yeah. Okay, we had one more question come through. There is no IAM or RBAC, ABAC that is practical with native capabilities or loach thereof. I don't know what that means.
Lack thereof.
Lack thereof. Thank you. Yeah. Any suggestion how to take that, Robert?
So I think what this is getting at is that there's no, it would be nice if you could add an RBAC rule that says these people are allowed to create workloads that run as root. These people are not, or this namespace is allowed to have things that run as root. This namespace is not. I think that's what this question is getting at. RBAC does not do that today. There was briefly a concept called pod security policies, which was kind of like this. They've since been deprecated. I think what the community has come to realize is that policy engines are really the best way to do this. Having just a pure kind of configuration syntax for it usually ends up not being powerful enough. And so a lot of folks are going with Polaris or OPA in order to set these rules, especially if it's on a per namespace or per workload type basis. Hopefully that answers the question here.
Great. And since there's no other questions with that, as we're getting close to time, I'll turn back over to you, Cody, and let you wrap us up. And you're going to start the interpretive dance before you give out the gift card, right?
I will start the interpretive dance after I give out those gift cards.
Okay.
So, Kendall, thank you so much. And Ivan, Robert, thank you both so much for joining us as well. I have seen a question about this session being recorded, so I will just remind everyone that the session was recorded. You will receive an email with a link to access the recording so you can watch it on demand, or you can find it living on the Container Journal website at containerjournal.com/webinars. So on to those 4 gift cards. Our winners, and these are for 4 $25 Amazon gift cards. Our winners are Batsurin B, Constance R, Zoe K, and Ilya K. So to our 4 winners, congratulations. Keep an eye on your inbox to claim that gift card, but if you don't happen to see an email, please do check your spam folder. I'd like to thank Fairwinds for sponsoring today's program, and to our audience who's joined us for the last 55 minutes. Thank you so much for being with us. We really value your time, but more so than that, we do value your feedback. And so we'll be popping up a survey as soon as we close out. We'd really like your feedback onto how we can improve on our programs, or what you'd like to see in future programs. Otherwise, we do hope to see everyone at a future TechStrong learning experience, and have a great rest of your day. Kendall, Robert, Ivan, thank you all so much.
Thanks, Cody.
That's good, Cody. I'm impressed.